Oh, no.
Day one quiz. All right. So let me get Blackboard open here. I think I unlocked the class, right? All right, so first of all, as usual, make sure you have an account set up on Slack. And join the channel CSC470. And it looks like somebody has leaked the textbook. So officially, let me talk about this. Let's go into the syllabus thing here. Well, I'm on the guest network. That seems to be dangerous, right? All right. So first of all, we are going to be using a programming language in here called Scheme. How many of you have ever heard of a language called Scheme? How many of you have heard of a language called Lisp? Okay, so Scheme is a superset of Lisp. Now, and I can, for those of you who want evidence, I can show it to you later. It's on Slack. When you're taking this class, you are going to hate Scheme. Okay, you're going to hate this class. This class, we are going to write a programming language. Okay, so in previous classes, you've learned how to program, learning programming as a skill set. And here we're going to learn, let's say that you were inventing a programming language. If you were implementing one, how would you write that? How would it work? Does that make sense? Okay, we're using a language called Scheme to do this because Scheme is a pretty simple language. That is, it's quick to learn. There's not that many moving parts to Scheme. Now, with that in mind, how many of you, remind me, what's recursion? What is, when I say recursion, what is that? Go ahead.
When a function calls itself.
Okay, function calls itself within itself. So everybody in here has been exposed to recursion at some level. How many of you say you really, really like recursion? How many of you would say you really dislike recursion? Most of you, right? It's kind of hard to think about it. I have bad news. So when we go back to the earlier programming classes, I usually advertise that programming languages provide facilities for remembering stuff, asking questions, and repetition, right? And typically when we think about repetition, our various options for repetition are loops, maybe functions, right? We can call a function multiple times, and possibly recursion, right? But we kind of avoid recursion like the plague because it's difficult. So the bad news is that Scheme does not support loops. So that means anytime you would need to do a loop, you actually will have to write it recursively. All of the time. Okay? Now the good news is, by the end of this class, you will have either changed majors or gotten very good at recursion. In fact, what ends up happening is when you come out of this class, you end up having trouble starting to think about problems iteratively because you are now used to thinking about them recursively, so you will come out significantly better at recursion. Now, when you're going through the class, though, you're not going to really like it very much, at least not at first, because it's going to be very hard for you to rewire your brain that way. But we've had at least one former student who messaged me earlier this summer. Actually, it might have been last semester. who said he just got a job making $90,000 a year as a scheme programmer. So it's not a complete waste of time. All right. And the reason I choose the language is because it is a simple, small language, so we can focus on the language building mechanics as opposed to the programming language itself. We think about languages we've been exposed to, like Java or Swift, that kind of stuff. These are very large languages, right? Whole bunch of libraries. I think I've made the comment before in some of my classes that I've been programming in Java since the day it came out. And I bet you I've only been exposed to 10 or 15, 20% of the whole language. You know, there's just a lot of stuff there, and you only are going to stumble upon the things that you actually need. Where Scheme, we're going to be using a relatively small set of Scheme, because actually there are some newer versions of Scheme that have introduced the idea of a loop for the week. Okay, they've effectively implemented a loop structure recursively. We're not allowed to use that, though. That's not what the cool kids do. All right. So in any case, why is this so huge on the screen? All right. So here's your normal syllabus, blah, blah, blah. Here's the official textbook for the class, Essentials of Programming Language, 3rd edition. I think you can get this on Amazon. Any of these places, probably somewhere where you can get it used for 20 or 30 bucks. Like I said, it has been leaked on Slack. Here is the book. I am not condoning you use that, but I didn't put it up there. So if you don't want to spend the money for the book, visit Slack and download it, I guess. Okay, and we'll start looking at the book here in a few minutes. Normal grading scale for my classes. Homework assignments, 45% of the grade. Pop quizzes, 15% of the grade. Midterm and a final, 20% each. Same policy as usual, where if you bomb the midterm, come back and do better on the final, I'll replace your midterm grade with whatever you get in the final, but not the other way around. Make sense? Okay. Something new I'm doing this semester. We just had our faculty retreat a couple weeks ago, which is like when all the faculty from Concordia, Wisconsin, and Concordia, Ann Arbor get together and we all talk about goals for the semester and things like this. And one of the things we're really focusing on this year in computer science is integrating a Christian worldview into the classroom. Now, as you might imagine, that's difficult to do in computer science. So what I'm going to do is we're going to have this is going to be one assignment per week, and it's always going to be due on Fridays. I'm putting up a Bible verse, and it's not a long thing, but you have to go read this chapter from the Bible and then write like a one-page, can be double-spaced response to it of how that applies to technology and computer science. All right? So this is going to be your opinion. If you are not a religious person, I'm not going to sit here and beat you over the head with the Bible, but it is a book you have to read for a class and give me a book report on it. If you are a Christian and you, hopefully this gives you an opportunity to kind of look at the Bible and God's Word and kind of see how it reflects to your vocation. Make sense? So first one's already up there. It's due this Friday. I think it's like Psalm 111 or something like that. That talks at least loosely about technology, and then you just write and say, what does it say to you in terms of how this relates to your degree or technology, that kind of stuff. Yeah.
Does this fall under homework assignments?
It does.
Cool.
Yep. So it's like free points. It's like that's true. I mean, you can look at it as free points as long as you do it, and you didn't like plagiarize what I don't want. So I guess let me expound on this a little bit. What I don't want you to do is I don't want you to go and look at this Bible verse, then go look up some study Bible's interpretation of Psalm 111 and give me the official interpretation of by some Bible scholar of what this means. I want to know what it means to you as it relates to computer science and technology. So realistically speaking, we should have several answers there's probably going to be some overlap, but hey, might say something different to you than it might be to somebody else. Make sense? Yeah.
What if you own a study Bible? Could you quote from it and say this?
Yeah, that's fine. Yeah, I want this to be something that you all experience. We're not gonna. I'm not gonna sit here and you know, get you in trouble for plagiarizing. But I want to see your own thoughts. But if you read something and you want to quote from it, say, hey, I read this and I really like this idea. Something like that. Like, for example, my very first semester here 11 years ago, I heard a senior seminar presentation. I think this is something Dr. Locklear says, and I'm sure other people have said it. He probably heard it from somebody else. But that this idea that technology amplifies what's in your heart. I kind of like that saying. And it also is something that kind of makes you feel bad about yourself. I've used the example in the past, like, I would never walk into Target and steal a DVD, right? But I've downloaded some movies off the internet before, so kind of technology allows me to do that because it's more difficult to get caught, right? I just set up a VPN. They're not going to be able to find me. It's that kind of thing, and it kind of makes you self-reflect on that statement, and not so much in a good way for me, but at the very least, I can say I think it's true. It does amplify what's in your heart. Yeah, so those will be homework assignments as well as our, let's say, programming assignments, which you will have often. So pretty much every class you will have programming assignments. The assignments, though, are going to be relatively short in terms of the amount of stuff you have to write. And this will make more sense here in a few minutes when we actually get into the book and I talk about that a little bit. You kind of see the nature of that. But at least early on, they're going to be quite difficult because it's all going to be very new to you. Okay? And I'll also give you fair warning that the book does read like stereo instructions. Okay? But early on, you will. I actually will say this: the book is actually quite well written. I've been using this same book. This is the third edition. I used the second edition for several years, but I've been using this book for a long time for this class. And when I took this class, when I was in school, we used this book. So this is something that I've been, working with for a while now, and it's actually quite well written. But like I said, there's this initial learning curve where it's using a whole lot of fancy mathy looking stuff and mathy sounding stuff that seems very intimidating at first until you kind of swish all the details away and realize that's actually not saying really difficult stuff. It's just kind of written in a scary way. All right. But by the end of this week, we'll be actually writing programming stuff. Things in Scheme, and we'll actually start it a little bit today, so I'll kind of get the ball rolling. But your first homework assignment is also up, and it's due on Wednesday. So the Bible thing is due Friday, but your first programming assignment, or however you want to think about it, is just one question. I think there's like 4 parts to it, but they're all like the same. It's the same question. Just do the same thing for all 4 of these questions, and it deals with ways of writing what's called inductive sets of data, ways of describing languages. So we want to start thinking about what a language is, and then further on, we're going to start talking about programming languages specifically. Okay, so any questions about grading or any of that jazz? All right, so I'll go ahead and pop open the book here. Okay, now, and actually, before I go any farther, let me just go back in here. And just hit back. So inside of the content folder for the class, I have a Scheme language documentation. So if you need to look stuff up, you can. Anything you'll need for any of the assignments, I will give you in class. So I'll even make that one blanket statement that you're only allowed to use the stuff I've introduced in class. That will protect me from you going out and finding some third-party library written in Scheme that solves some of these problems. All right, because there is a reason why the assignments are written the way they're written. I use exercises from the book. They take you down this path, and it's similar to what I've done in my classes in the past, where I'll give you an assignment that seems really difficult, then we'll come back, we'll solve it the way I intended you to solve it, then I'll show you a better way of solving it, that kind of stuff. So kind of, let's say, enjoy the experience. But you will need the Scheme interpreter. And the one I use is this thing called, it used to be called Dr. Scheme. Now it's called, well, then it was called Dr. Racket. Now it looks like it's just called Racket. Okay, so I gave you a link. It goes right to the download page. So for me, I'm on a Mac, but it's available for Linux, for Windows, whatever. So go ahead and get that guy downloaded, and this is what you'll need for doing all your assignments and that stuff. And we'll probably actually use it a little bit today. Let me get Keynote open here. Why am I just being introduced to this now? Can I actually not? All right, so let's start a new. It seems like this is everything is kind of like too big right now, doesn't it? I guess I'll figure it out for next time. All right, so this is CSC470. All right, so let's start talking about some of our scheme primitive functions. Just get this guy shut there. All right, so these are going to be fun. So scheme is what's known as a list-based language. Now, I've mentioned several times when you took Java that I say Java is a string-based language. If you can get something into the form of a string in Java, you can do a lot of stuff with it. Same thing's true in C#, same thing's less true in Swift, but it should be more true than it is. Swift kind of protects strings in a funny way. But in any case, the equivalent of that in Scheme is a list. So a list in Scheme looks like that. We have this little quote in front of it, then an opening parenthesis, followed by something, followed by a closing parenthesis. This guy right here would be called the empty list. Similar to the empty string. Okay, and if you think back to Java, what do we use empty strings for? For building up strings, right? Same thing's true with this. What do we use the empty list for? For building up lists. So an example of a list might be something like 1, 2, 3. That would be a list. Okay. Now I have that little single quote before that guy, and that's important when we are using when we're writing explicit values. Okay. The reason I say that is because I mentioned that Scheme is a functional language. Remember way back when you first started learning programming languages with me, I mentioned this thing about there are 3 kinds of programming languages. We have procedural languages, we have object-oriented languages, and then we have functional languages, but I don't really want to talk about those. Kind of remember that conversation? Okay. So now we're dealing with a functional language. Functional languages make their calls in terms of functions, and the functions are list-based functions. So for instance, if I didn't put that quote in there, I just wrote it like this, it would be attempting to call a function named 1 and applying it to the parameters 2 and 3. That's why you need the quote when you're just putting explicit values. Okay? So having said that, let me introduce our first 2, well, really our first 3 functions. We have car, we have cooter, and we have cons. All right. Very, very fun. And you are not going to like these once we get into it either. All right, so what does car do? Car returns the first element in a list. Cooter returns the rest of the list minus the first element. Cons constructs lists where parameters are elements, well, an element, and a list. as an example, if I say car, this is going to just roll with the capitalization. 1, 2, 3, like that, this is going to give me the value 1. So I'm calling, so notice that everything's in parentheses here. This is the function car being applied to this parameter. That is the list containing 1, 2, 3. The first element of that list is the number 1. Make sense? Similarly, I can say car of the list containing 3 lists. So here's a list containing 3 1 lists. This is the list containing a 1. This is a list containing a 2. This is a list containing a 3, all held inside of a list. And when I get the car of that list, the first element of that is actually the list containing the 1. That makes sense? Now, if I wanted to get the actual 1, I would take the car of the car. Car of the car of all that would give me the actual 1. That's taking the car of the car. So the car of this guy is the first element of that list, which is a 1. That make sense? Another way of writing that, though, is C-A-A-R, the car. Just wait till we get into the cadatters, where you can't even pronounce it anymore. It gets fun, yeah. Yeah, so remember way back when we first started programming, I said, whenever you write something, and most of our IDEs today do this for us. They give us, when we put an opening curly brace, it gives us a closing one. Yeah, you're going to want to really do that with parentheses. So when you start a new function, put the opening parenthesis, put the closing parenthesis, because this list of a bunch of parentheses there at the end, that's child's play compared to what you're going to be looking at. You might get to some of these things that have 15, 20, 30 parentheses at the end. Just you don't want to be in that situation of just keep adding parentheses until it works, because you might actually have parentheses that you might put an extra 2 parentheses here at the end when they actually should be somewhere here in the middle. All right, when you create an opening parenthesis, create the corresponding closing parenthesis immediately. You'll thank me later. You won't do it, but you'll wish you did. All right, so this guy down here, the CAAR, that's a shortcut. You never have to use those. You can always just nest, take the car of the car. In fact, at the end of the day, I usually prefer that. I think when you have to start thinking around corners with the car of the car, it gets a little bit wonky. All right, so that's car. Now, cdr, this gives us everything but the car as a list. So if I take the cdr of the list 1, 2, 3, this will produce for me the list 2, 3. Everything other than what's returned by the car as a list. That make sense? That's what cdr gives me. If I want the cdr of the cdr, cddr of 1, 2, 3, that would give me the list 3. That makes sense? Or I could say the cdr of that list. So I can nest them like I did up here with the cars. Now, cons allows us to build lists. So for instance, I can cons a 1 onto the cons of a 2 onto the empty list. And what this would produce is, so this inside cons here would cons a 2 onto an empty list, which would give me the list 2. Then I'm consing a 1 onto that, which will give me the list 1, 2. So it allows me to build lists, construct lists. That make sense? Don't confuse that, though, with this. Cons of 1 onto 2. Because what this, well, first of all, depending on which mode you have the scheme interpreter in, this will either give you an error or it'll give you something that looks like that. It's a dot notation, and if you ever get dot notation, that's not what you want. You're in a bad place. So the second parameter of the cons function is always a list. Okay, it doesn't have to be the empty list. I can say cons of 1 onto the list 2, 3, and this would produce for me the list 1, 2, 3. That makes sense? All right, so that is, go ahead.
With cons, can you do the double O like you did with CDR and card?
No.
No.
You know, at least I'm 99% I've never seen it.
Okay.
It's possible it exists, but I don't think so. I think I've only seen it with the cars and the cooters. But having said that, kind of like before when I indicated that maybe my preference is to not link them together, or if you're going to use like a CADR or something like that, like a catter, that's kind of using them together. CADR, that's the car of the cooter. That's maybe okay if you're just going kind of 2 levels in like that, but there is a limit to how many of those things you can nest. So you can say like the CAADDADDAR of this thing, and you go insane, right? And depending on the interpreter, only lets you go so far. My preference usually is just nest them yourself, or if you only need to go 2 levels, get the catter of it, that's probably okay. Yeah.
So like you were saying that like the car is the same thing as like the car with 2 A's?
Correct.
So
These two right here are identical to each other.
Then why does it give you a different answer?
It shouldn't. I copied from up there. It doesn't give you a different answer. It gives you the same answer. I had copied from this guy.
So it's just 1.
Yeah. This gives me the car of the car. So the car of that guy is the list 1. The car of that is the 1. It's written better now. I had made a mistake because I copied from this for my parameter.
You still have
A who?
quotation.
Oh, thank you. Now it's written even better. See, I'm always testing you. You passed in this case. Twice. Passed twice. All right. It's 2017, right? It's when you get old, you start forgetting what year it is. I mean, actually, you're probably not old enough to forget which birthday it is yet, right? All of you kind of know which birthday is coming up. Eventually, you got to do the math. It's like, how old am I? Usually right around that 21st birthday, you pretty much know what's going on. And then the 16th birthday, although that's not when you get your license anymore, is it? 16? I thought you start driving at 15 with
Yeah, 15 and a half years old first.
can't you drive with friends when you're 15?
No.
Oh, okay. So I thought things had changed. Maybe not. Okay. So that is our initial functions that you'll have to look at. Let me actually go ahead and just show you one additional one, because you will see it in the book when you read it. There's something called a define. So this goes back to all programming languages have facilities for memory, asking questions, and repetition, right? So the facility for memory in Scheme is something called a define function. This allows you to define a variable name with a corresponding value. All right, so define defines a variable name with a corresponding value. Now, the kicker here, though, is we are used to our values in our common languages that we've worked with being our primitive types, like ints and chars and booleans, those things. Also object types, strings, characters, linked lists, stacks, those types of things, right? Now, what we're not necessarily used to, well, we are, but it was kind of hidden from us. When you define a function in Java, for example, if you say void, do something, open, close parentheses, blah, 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 that's a function definition, right? Or a method definition, however you want to think about it. But you don't necessarily think about that in the same light as defining int a equals 7. But really it is. You're creating a variable name, and you're assigning it a value, which is a function. Does that make sense? Just uses a little bit different syntax. We think in Java or C# or any of these languages, you have this idea that, oh, well, there's a special syntax for functions, and it's special enough that we don't really equate it to being the same thing as saying int a equals 5. But really, it is the same thing. You're defining a place in memory with a name, and you're associating with that a value. Make sense? All of it in Scheme is done with the define function. So values can come in the form of numbers. It could be the form of a list. It could be form of it could be a character primitive, but they're not really common. We do a lot of our stuff with well, they will be common before long when we have to like match like if statements and stuff. But any of our primitive types, of which right now I'm going to say all you have to worry about is lists and numbers. That'll hold you over for a while. Okay, lists and numbers. But also functions. When we write a function in Scheme, so if I want to create a variable, I can say define a is equal to 5. That'll create a variable named a and set it equal to the value of 5. So from that point forward, I can use a as a value. Okay? But I can also say define b to be the list 1, 2, 3. Now I can also say, now you're not going to need this quite yet, but you are going to see it in your reading in the book. So I'll scare you a little bit. Okay, and we're going to get into this really quickly. So probably next class we'll be doing this. So I'm going to say define C to be a lambda x, something like that. So what this is saying, let me see, I'm going to steal this and put it on another slide just so it's larger for you for the moment. That easier to read? Okay. So what this guy says is I'm going to create a variable named C. And the value this guy is going to be equal to is this dude right here. Now the question is what is that dude? Well, right off the bat, for most of us, the guy should look a little scary because it's got Greek names in it and stuff, right? So a lambda are actually quite prevalent in Scheme and actually in language design. What a lambda is an unnamed function. So lambda is how we implement functions in Scheme. Define is how we assign a name to it. So this is a function that takes one parameter. What does it do with that parameter? It adds 1 to it. In that particular case. Okay, so lambdas are how functions are defined in Scheme. And we'll see these a lot. I just wanted you to kind of see it right off the bat because you are going to see it in the book. Okay, so now, any questions about any of that stuff? You actually won't need any of this stuff for your first homework assignment that's due Wednesday. So, but the book does give you a couple of examples where they do write some Scheme. So hopefully now you know kind of enough to be dangerous for kind of looking at those examples, even though those examples aren't actually related to what you're doing for the first homework assignment. I think there's actually only one example. They just happen to show you the Scheme code for it. Okay, so let me just take a few minutes here and flip through the book just to show you. So we're going to start off. So right off here, we're dealing with inductive sets of data in chapter 1, which just sounds thrilling, right? All right. So really what we're doing here, so for Wednesday, I want you to read section 1.1, okay? And then do the very first exercise from the end of section 1.1. I think it's exercise 1.1.1, okay? And I'll show that to you here in a second. Get through this fluff here. But effectively what we're doing here is we're figuring out how to formally define a language. But at this point, I want you to think of languages as not necessarily being programming languages, but more just patterns of stuff for us right now. So for instance, the language of numbers, we all know that one, right? The language of numbers are, at least in decimal, for decimal numbers, are numbers containing the digits 1 through 9. Well, 0 through 9, correct? Okay, but numbers typically don't start with a 0. So we have to have a formal way of defining that language. So as an example here, I think the very first thing shows you the language that's stepping by threes. Yeah, so this is the inductive sets of data. So you'll read through this recursively specified data stuff. And for example, here is one of the things. So one way you can describe a language, and they're going to show you 3 different ways of describing a language. And your first exercise is, here are 4 languages, describe them in all 3 ways. And you're not going to actually have to do this very often after this first class. In fact, the real benefit of this is so that you can read it. They're having you do it because from that point forward in the book, that's how they'll show you languages. So you need to be able to read that format. Okay? So if you find this kind of cryptic and boring for this first assignment, it might not be all that easy, but it's more of kind of a mathy, just write stuff in the right way type thing. That's not what this class is going to be about. You'll just have to be able to read those. And you'll find that they're easier to read than they are to write. All right? But as an example, one way you can denote this language. So this is, if we have a natural number n, and we have a language name s, n is part of that language if n is either 0 or n minus 3 is included in s. So that means 3 would be a number in there because 3 minus 3 is 0, and we've given that 0 is in the language. 6 would be in the language because 6 minus 3 is 3, 3 minus 3 is 0, and we've given that 0 is in the language. Does that make sense? So this describes the pattern of that language. We have 1 given, 0 is part of the language, and then any number that when we subtract 3 from it, any number n, when subtracting 3, if that's ultimately in the language, then that number is also in the language. So like I said, the example of 3 minus 3, we're asking the question, is 3 in the language? Well, is 3 minus 3 in the language? 3 minus 3 is 0. Yes, that's in the language by rule 1. 6, is 6 minus 3 in the language? Well, 6 minus 3 is 3. Well, is 3 in the language? Well, 3 minus 3 is 0, and 0 is in language. So yes, 6 is in the language because 3 is in the language because 0 is in the language. Kind of makes sense how that happens? So this is one way of describing it. And then they go through, and here's kind of the some scheme they use to show that, kind of unimportant. And then they show you alternative ways of describing the same stuff. This says 0 is in the language, n is in the language if and only if n plus 3 is in the language. Different ways of saying the exact same thing. Okay, so for your assignment for Wednesday, you're going to read through these, look at these examples. This kind of tells you how the thing works. And then you're going to complete exercise 1.1, which is a 1-star exercise, which just has you rewrite these things in the 3 different ways, if for no other reason than just to get used to reading it. Make sense? Questions, comments, concerns, bribes? Okay, well, I got to run. I'll make sure I get the video up and posted. I will see you all Wednesday. Make sure you get on Slack and join the 470 channel. And let me know if you have any questions, and I'll see you when I see you.